Assalamu alaikum, dear students. Today we shall discuss the higher order derivatives. Now let y equals to f of x be a given function, and if this f is differentiable, this means that dy by dx at a given point or at any point exists because it is differentiable. We simply denote this derivative at a point by dy by dx equals to f dash of x or by df by dx. Now at a given point, because this is the local property means that we discuss differentiability at a point, not at a set. Now at this point, that its geometrical interpretation is simply that it gives us the slope of the tangent at a given point, or we simply say that it gives us the rate of change of this variable, means of this y with respect to x at a given point. That is dy by dx at a given point simply gives us the rate of change of the quantity. Now if we differentiate this function again, that is if we differentiate this dy by dx, we get the second order derivative. Now what is second order derivative? Now this differentiation simply means, or the derivative simply means, the rate of change of the quantity, means rate of change of the variable. Now here consider this as a variable, this dy by dx here. Like if we consider y, we consider this dy by dx as y. Now if we have to find the rate of change of this slope, because dy by dx at a point is slope with respect to the x-axis at a point. So this means that if we have to find the rate of change of this slope with respect to the point on x-axis, what does it gives, or what is its geometrical interpretation? Usually the differentiable functions, we have two clauses. One, that clause in which we consider the constants or the identity functions, means those functions whose graph is straight. Or second class is non-constant, non-identity functions whose graph is not straight, simply the curved graphs. Now this is the straight graph. Here if we consider point B on domain, at point B we have a tangent which is which coincides with this straight line. Similarly, if we consider the neighboring point of this B, that is say B plus delta, at this point if we have to find its tangent, that tangent is also the line, that tangent is also a line which coincides with this straight line. So this means that for two straight lines, for two identical straight lines, the slopes are same. When slopes are same, this means that a rate of change of this slope is 0. Now if we consider non-identity or non-constant functions like this, here we have curved graph, B is the point, at point B we have a slope, we have a tangent whose slope is theta1, and at point B plus delta, which is neighboring point of this B, we have a tangent whose slope is theta2. Here we have at two different points, we have two different tangents with two different slopes, which implies that when we have two different quantities, so there is the rate of change. So this rate of change is simply given by this second order and derivative. So simply we can say that this rate of change of the slope, gives us the information about the behavior of the curve, or about the behavior of the function, that is simply called as the curvature. Now this rate of change means this rate of change of the slope with respect to the point on the x-axis is called as the second order derivative at that point. Now if we consider function is y equals to f of x, dy by dx is f dash of x, we can simply write this as d by dx of f of x. This is the first order derivative. Now change in this change with respect to the point on x-axis, because this is the change. If we have to find the change with respect to this change, we simply write this by dx of dy by dx, which is d by dx of f of x, or simply we write d2, because in this we have two d's, that is d2y upon dx square is d2 by dx square of f of x, or we simply write this or symbolize this by f double dash of x. This f double dash of x is called as the second order derivative at a given point. If this is 0, this means that the graph is actually straight, and if this is non-zero, this means that the graph is not straight. We have the curved graph of the function. Similarly, we can have d3y upon dx square, which is called as the third order derivative, or dny upon dxn, which is dn f of x by dxn, which is called as the nth order derivative. These nth order derivatives are obtained from a given function by differentiating the given function n times. Like find d3y upon dx cube means we have to find the third order derivative of this given function, where given function is y equals to x cube plus 2x square. For this we have to firstly find the first order derivative, that is obtained by differentiating the given function, which is dy by dx, which is simply 3x square plus 2, because differentiation of x cube is 3x square, while as differentiation of 2x is simply 2. Now from this, which is y1, from this dy by dx we find this d2y by dx square by differentiating this. When we differentiate it is d2y upon dx square, which is 6x plus 0, because differentiation of constant is 0. This is the second order derivative. From for third order derivative, we differentiate the second order derivative, that is d3y upon dx cube is simply 6. So this is the third order derivative. Find f double dash of x means we have to find the second order derivative for f of x equals to cos x. This is by differentiating, it is f dash of x is minus sin x. This is the first order derivative, while f double dash is obtained by differentiating f dash. It is simply, now differentiation of this sign is cos, which implies that differentiation of minus sign is minus cos x. Hence this is required f double dash of x means second order derivative. Sometimes we denote this dny upon dxn by yn, that is we denote d2y upon dx square by y2, we denote d3y upon dx cube by y3, or simply we denote dy by dx by y1. This means that y1 is first order derivative, y2 is second order derivative, y3 is third order derivative, or yn is nth order derivative. Find the second order derivative for f of x equals to sin x, sine of log x. Now here given function is f of x, which implies that when we differentiate this, we get f dash of x. Now differentiation of this sign is cos log of x, and differentiation of this log is 1 upon x, which implies that f dash of x is cos of log x upon x, which is first order derivative. Now we have to find here the second order. This means that we have to again differentiate this function with respect to x. So we simply get f double dash of x equals to, now here we have function which is quotient of two functions, cos of log x and x. In denominator we have to x, and in numerator we have cos of log x. So using the quotient rule of differentiation, we simply get f double dash equals to minus sine of log x minus x cos log x upon x square, by using the quotient rule, which you already know. Now if y equals to cos inverse x, we have to find d2y upon dx square in terms of y. Now here y is cos inverse x. You know that the differentiation of cos inverse is minus 1 upon root of 1 minus x square, which implies that dy by dx is minus 1 upon root of 1 minus x square. Here this root means index is 1 upon 2, and this root is in denominator. So when we simply write this, we get dy by dx is minus 1 minus x square upon minus 1 by 2, by shifting this denominator to numerator, that is minus 1 by 2. Now we have to find the second order derivative, which implies that we have to differentiate again this dy by dx with respect to x. So we get d2y by dx square is by using x raised to power n formula. You know that the differentiation of x raised to power n is nx n minus 1, which implies that by considering 1 minus x square as x and n as minus 1 by 2, you get minus x into 1 minus x square raised to power minus 3 by 2 is the second order derivative. Now we have to replace this, or we have to write this d2y by dx square in terms of y, where this y is cos inverse x, which implies that cos y is x. So d2y by dx square becomes minus x into 1 minus x square whole raised to power minus 3 by 2 is minus cos y into 1 minus cos square y whole raised to power minus 3 by 2. This 1 minus cos square is sin square, which implies that we get minus cos y into sin square whole raised to power minus 3 by 2, or minus cos y into sin minus raised to power 3, because 2 and 2 will cancel, or simply we get minus cos y upon sin cube y. Cos upon sin is cot, that is cot y. Then we are left with 1 upon sin square, and 1 upon sin is cosec, which implies that we get 1 upon sin square is cosec square y. Hence d2y upon dx square is minus cot y into cosec square y. So this means that this d2y by dx square is completely in y's. Hence d2y by dx square is minus cot y into cosec square y, which is the required result. Now if y equals to 3 cos log x plus 4 sin log x, we have to show that this x square y2 plus xy1 plus y equals to 0. That is, y2 is here second order derivative, y1 is first order derivative. So we have to differentiate this y with respect to x 2 times. Now when we differentiate given with respect to x, we get dy by dx is minus 3 sin log of x upon x, because differentiation of cos is minus sin, that is minus sin log x, and differentiation of this log x is 1 by x, that is minus 3 sin log x upon x, plus 4 cos log x upon x, because differentiation of this 4 sin log x is 4 cos log x upon x. Now here this dy by dx is y1, so this means that y1 equals to minus 3 sin log x upon x plus 4 cos log x upon x. Now we have to find y2. This means that we have to again differentiate this, y1 with respect to x. When we differentiate, we simply get d2y upon dx square, that's y2 is, here we have two functions, one is this, second one is this, both are the quotients. So using the quotient rule of differentiation two times, firstly in this function and second in this function, when we differentiate it, we simply get d2y upon dx square is minus 3 cos, this one minus 3 cos log x plus 3 sin log x minus 4 sin log x minus 4 cos log x upon x square. Now here I will arrange these terms. In this we have negative, and here we have negative minus 4. So by taking minus out, we simply get minus 3 into 3 cos log x plus 4 sin log x. Here we have plus 1 minus 1. So taking minus 1 common, we simply get minus of minus 3 sin log x plus 4 cos log x. Here this 3 cos log x plus 4 sin log x is given function, that is y. This means that it is minus y. Now when we multiply and divide this term by x, we get x into minus 3 sin log x plus 4 cos log x upon x. Why I multiply and divide this by x? Because I need here y1, and y1 we have x in the denominator. That is why I have to multiply and divide this term by x. So here this term except x is y1, which implies that y2 is minus y minus x into y1 upon x square, or by cross multiplication we simply get x square into y2 equals to minus y minus x1 minus y1, which implies that by shifting terms we get x square y2 plus x y1 plus y equals to 0. So this is the required result. Hence we proved that x square y2 plus x y1 plus y equals to 0. So in this way we completed this very topic, that is higher order derivatives. You can find any order derivative by differentiating that times the given function. Inshallah, in tomorrow's video lecture we will discuss one of the important theorem of this in this differentiation, which is mean value theorem. So thank you.